And then I'll start the webinar. Because then I won't have that playback. And then I'll start the webinar. Okay. Oh, that's me talking to myself. Because then I won't have that playback.
It still says I'm in a practice session. It's not it's not started. Is it?
Mm-hmm.
It goes. Now it's started.
And then I'll start the webinar. Okay. Oh, that's me talking to myself. Because then I won't have that playback.
It still says I'm in a practice session. It's not start. Oh, it's why is it record? You're playing a recording.
Mm-hmm.
It goes. Now it's started.
Then I'll start the webinar.
What is going on?
Oh, I do know. Hold on, everyone.
It's probably delayed on YouTube, and we're hearing it.
There we go. I forgot to silence the video on the computer. So we can remember this for next time. I forget. Every time we do something new, I mess that part up. I always forget.
We have one attendee.
Yay! Who's our one attendee?
Dev. Welcome, Dev.
Nice. Nice. I know I talked to a parent, actually a community member at large, and they have a 6-year-old who's not, he goes to a different school within our district. And so they had asked for the link. So that's fun. Should we go ahead? We've got a little bit of time.
Yeah, maybe wait the 2 or 3 minutes till it officially
starts. Deb, do you know how the webinars work? You can use the chat to communicate with us. You can also use the Q&A, and we encourage you to do that because we want to be able to answer all your questions. So if you don't know, raise your hand or put in the chat, just put in the chat there. They know how a webinar works. All right, wonderful. By now, right? This used to be a question that we have to ask people, but now everyone knows how it works now. Thank you for being here. Did you participate last year in the program? Yay. Okay, so we have a return. Nice. And I don't remember, were you here last week? I feel like you weren't here last week, which is fine. You don't have to, it's not a requirement. But I can't remember if you were here last week with us. We might want to, I forgot to ask you guys, at the bottom of the first slide, you guys see the slide deck of resources? Okay, it was not. Can somebody pull that link off and get it in the chat for us? So we're going to put a link in the chat for you. It's from last week, and it has everything that we kind of covered last week. It's got a lot more detail than what we're going to go over today.
Oh.
Of course, today we want to spend our time learning from Ms. Peggy.
So you want the kickoff from last week.
So yeah, there you go. It's in.
Okay, someone got it.
We're good. All right, and then we do have 3 people watching from YouTube. And so let me transfer it over to Facebook as well. And then I think we might be ready to roll. We have really gotten good at technology. I just want to shout out to my amazing team that I work with. All right. All right, it's 6 o'clock. And so I think we're ready now. Wonderful. Well, we want to share some information about the STEM Expo. So we're going to do a quick overview, 15 minutes or less, of some of the information we talked about the last time. We are going to put in the chat, and we can, if you're watching us on YouTube or on Facebook, we'll link those resources, the slide deck resource in those resources as well for you, so that you can, get all the information and the updates about what we're working on and how this event's going to go. So first thing is the STEM Expo. We're doing a little bit later this year. We're going to do this on April 30th. It's a Saturday. Registration is going to open in February on our last event. Next week, we're also going to be doing a cool sky show, so don't miss that. It'll be different topics than today, but it will be a sky show as well. And we're doing that because normally the planetarium, we offer 4 public shows a school year, and with COVID, we're unable to do that. So we have the wonderful Mrs. Hernandez, and she's going to do a sky show, and we're going to get those going again next year, right, Mrs. Hernandez?
Yep.
COVID willing, I guess.
Mm-hmm. Yes.
All right. And so then before we go much further, I'm Deb McMullen. I'm your science coordinator, and I'd love for everyone, all my staff, to introduce themselves. So who wants to go next?
Hi, I'm Vince Fosco. I'm the elementary science instructional coach.
I'm Frankie Valencia. I am the secondary.
And I'm Peggy Hernandez, and I am the planetarium teacher.
Hi, I'm Sarah Rodriguez Horn, and I am the secretary for K-12 Science.
Yes. So that is us. We're going to, through this process, we hope to learn more about each of you. We've had a lot of fun over the last years, just really getting to know the students who are doing these events and supporting you. And we will support you. So when you email us and ask for help, one of the 5 of us, or maybe all 5 of us, are going to weigh in and help you and make sure that you get the information you need. So don't be afraid to ask us questions. All right. Hold on. I'm having a little trouble here. Let me move that. There we go. Okay. So we're going to give you an overview of the STEM Expo. We're going to provide you some ideas and resources, and we're going to get you thinking. And we're going to do that actively. So we're actually hoping that you will interact with us and you'll send us questions. You can send them on YouTube. You can send them on Facebook, or you can, those of you participating here, you can also send us questions. Next kickoff event is the February 2nd, and then February 9th is going to be our last kickoff event. And that one, Ms. Hernandez, would you mind telling us about our special guest on February 9th? I think it's fitting. Oh, you're.
On February 9th, a former Eastview student, Bartlett, one of the Bartlett schools for elementary, I don't remember which one, maybe Sycamore Trails, Eastview, and then Bartlett High School graduate, a student that I had when I taught 8th grade at Eastview for 15 years. She runs the collections. She's the collections manager in Salt Lake City at the Natural History Museum there. She is a paleontologist, and she does field work, digging up dinosaurs, and she's done so many cool things. I invited her to come and speak a little bit about the STEM Expo and some of the science stuff that she does for her career. And she was happy to do it. And so she'll be our guest speaker for the middle half hour on that last and final STEM Expo kickoff on February 9th, a Bartlett native.
So this one's going to be fun tonight. Next week's is going to be fun, and the last one is going to be really, really fun too. I'm looking forward to all of them, but especially learning from Carrie because she was great last year. I don't know if you.
Yeah, she went down into the archives, into the basement of the museum where they keep all the collections, and she pulled out drawers and showed us some really neat fossils.
Yeah, it was amazing. A once in a lifetime, probably, to get a chance to look at those. So what to expect in the STEM Expo this year, it's going to be both, you can have an in-person option, but you could also, we are going to have a virtual option for folks. So it'll be fewer participants in the virtual format, and the in-person format will be where we hope to get the most people. It's going to be held at Eastview Middle School this year. And also, you do not have to be a U46 student to participate in the STEM Expo. The STEM Expo is open to any student who lives within our boundaries. So if you have a friend who maybe goes to St. Joe's or something like that, and you want to do a project with them, you can do that. Everyone is welcome to this event. It's really fun. The in-person events, we typically have about 300 projects live, and we have about 1,000 people who come on that day to come see everything. So we are working through the COVID to make sure it's social distancing. So right now we're thinking about where it's probably gonna be more staggered. It won't be that 1,000 people all at once, but we'll be giving you all those details and making it obviously social distanced and safe, for sure. So you will register via a Google form, and we're going to open that on February 9th, right after we hear from our wonderful guest. The event is going to be hosted again in person via Zoom. We do have a third option. So let's say that you're just a little shy and you really don't want to do a Zoom presentation or an in-person presentation. We're totally fine with you sending us a video of you presenting, and we will make sure that you get feedback. So you could also record yourself doing the presentation and submit that. Our event is not judged, and it's really important that we help you understand that it's not judged. Because I don't think, science isn't judged in terms of a contest of who's the best project. Science is all about people working together to learn information, sharing information, providing really good pushback on how did you get this and why do you think that? And so we want you to know that this is not a judged event. Mrs. Hernandez, do you want to speak anything to that? Why we're so passionate?
Yeah. I think we need to emphasize that this is not a science fair like my parents did and I did. And I had to come up with a list of materials and then a procedure. And then I had to do an experiment. And then I had to have my results. And then I had to write a conclusion. Now, there's nothing wrong with what I just said. That's experimenting. But the next generation science standards don't emphasize just experimenting. All parts of science are really, really important. So the STEM Expo project is based more on your science and engineering practices and these big cross-cutting concepts, these ideas in science that kind of connect all sciences together. And we want to see that you're well-rounded, not necessarily that you can find a really good science fair project that somebody else did on the internet and try to mimic the same thing. It shouldn't be a cookbook. You're not following a cookbook recipe, and you're not going to try to do an experiment that gives you an answer that you already know. That's what we want for the Science Expo.
And we're going to give you an example of what that might look like here in a moment. What's more important to us is that we're creating a community of scientists. And in U46, we talk to each other as scientists, and we share what we were learning, and we share our failures, because actually failing in science is an answer, and it's really important. Failure is a very big part of it. And so exactly like Mrs. Hernandez said, we want to create a culture of learning. We want your original work. We want to know what you guys think is happening in the world.
And don't feel like you're missing parts of it if you spend a lot of time learning a lot of science. You don't have to follow some recipe or a number of steps that you find in an old book about science projects. That's
Yeah.
what.
It's just what you're curious about. We are looking for some volunteers. We need folks to help us out to be peer panel members, meaning working with students and asking them questions about their project to help them think through it. We also need volunteers very often to help us run the event with, various different stations that we might put someone. And then community partners, we're always looking for those. Anyone can be a community partner. So you might be out and you might see a cool scientific phenomenon that you want to send a photo of or a video of or an idea for to our office. And then we will share it out with people to give them an idea. We'll add it to our list of cool things that you could investigate. So there's a lot of different ways that you can be involved with us. At the bottom of the screen there, you'll see my email, and I'll be sure to give you that in the chat so that you can get a hold of me and share that with us. So thinking about your project is what we want to spend just a little bit of time on. And actually then Miss Hernandez is going to do a program, which you're going to be still thinking about projects, because our idea today is to just give you some ideas, wanting you to come away with some things you might be interested in doing. We have in that slide deck that we put in the chat, it has links to all of these, there's an in-person link, a presentation board link, like we've got lots of information to help you build out these projects and give you ideas for how you could present them. And so we want to just kind of practice that a little bit today. We'll get to the details as we go a little bit more.
And you know what, let me go back to that one.
Oh, sure.
There's no link there. It says link to virtual pre-recorded presentation. And so it's not linked because we didn't update it yet from last year. But if you, in doing a presentation, you can do it on a PowerPoint that a slide deck that we already made for you. And you just fill in the blanks of what your project is. It asks you about what you're thinking. How did you come up with that idea? Why do you think those are connected? What's your explanation for this? And it makes it really easy, because to do your project, if you're going to not do it in person, if you're going to record it or you're going to do it online, you have a slide deck that it will already be made, and you can just put in your answers. So it makes it really easy to do a pre-recorded or just an online presentation. It's just not there, and we will be putting that in soon.
We are going to be stopping for question and answer. I did notice a couple, there's a student that keeps raising their hand. If you wouldn't mind, you can either put your question directly in the chat, or in the bottom of your screen, there is a Q&A feature that you can also put your question in. And we're anticipating you having lots of questions as we proceed. So just get used to using either one of those, and we will stop and pause and answer your question that way if you don't mind. All right, so we thought we would try this out. Now I'm going to have to stop screen sharing here for a second, but we found a video, and I need to just exit this to be able to get to the video and then re-screen share. Sorry for the flip around here. Let me put the sound in. Okay. I have a lot of tabs open. Okay. So we're just going to watch this, and while you're watching this, we want you to be thinking about questions you might have. I think you get the idea. So in the chat or in the Q&A, what questions do you guys have about that? I mean, this is an example of a phenomenon, right? First of all, what did you see? Let's talk about what was it that we just saw. So in the chat or the Q&A, tell us what you saw, what just happened, and then what questions do you have about it? We're highly participatory here. It's okay. And if you put it in the Q&A, no one else sees it but us. If you put it in the chat, everyone sees it. If you put in Q&A, only we see it. Oh, this is a great one. Would this work on ice that is stuck to the ground very well? So like, mavis and grass. I think that's a great question. What else we've got going on here? Oh, was hot air coming out? How does the air break the ice? And how, just the general question of, I'd never seen this, that a leaf blower could break up ice. All right, what else we have in here? So how do you think it's happening? So if you had to make a guess as to why this is happening, so if you put it in Q&A, the only people that see it is us, but if you want to put it in the chat, everyone in the webinar can see it. How is this working? How do you, any guesses of why you think that this is working? Was the asphalt, so was the road a little warm, so it was already loose? That's a good guess. Maybe the asphalt or the road was a little warm and made it loose, melt the ice a little bit. Any other guesses of how that might work? No? Is there a little crack of air? So for the air to get in, and maybe it's a pushing force, right? So maybe the air is a little bit of a crack and it's allowing it to push up. And maybe that's why it's breaking. Is air getting in between the two and then there's lift? Is it forming some kind of lift that's allowing it to come up? Anybody else have any other guesses? Those are all good guesses. My question, Ms. Hernandez, if you wanted to pick any, like thinking of all the things that we did, is there one that you think is, vibrations? Could it be from vibrations somehow? Air goes under the edge and then it causes the fracturing. My question to either Mrs. Hernandez or any of the people in the webinar, are any of the things we proposed so far testable? Did we test any of these things? How might we test some of them?
We could measure the temperature of the asphalt versus the temperature of the air. Maybe it was melting underneath anyway.
I think, and that'd be pretty easy to do, to measure that and measure the distance. Yeah.
I don't know how to measure the cracking. Oh.
Of how it would, could you, I think it would also might be hard to measure, to get a measurement of like the pressure from the, would it be difficult? Because you could measure the force of the air coming out of the blower, but would we have to think about how that pressure might change? Because it's obviously getting under the ice, right? And so then we go from the blower to, the ice, the distance between here and here. We'd have to know how to figure that out. But I think those things are all doable. And so kind of our point of this, you guys, is that anything that you see, and it could be a video, like this was a video that our staff was just curious about. Our office, we're sort of nerdy. And so somebody found this and we were all talking about how does this work? But something like this could lead to your project. It could be something you notice. It could be a video you see. It could be, there's always funny stuff on different social media. It could be something that you decide to explain there, or it could be some other question that you have. The thing that we want you to know is that we would like your project to come from something you see, something you observe, something you're truly interested in, because we think that makes a lot of authentic work, and we want to support you in doing some authentic work. So we just wanted to give you a little example of how we as scientists work. I'm going to go ahead and I think Ms. Hernandez, you're going to go ahead and start sharing.
Okay. I think I'm screen sharing, right?
Yes, you are.
There we go. So there's the planetarium that your bus pulls up to when you come for a visit, a lesson at the planetarium. But just like that blower example, any project can be something that starts with a phenomenon that interests you. And it really can be almost anything as long as it's something that truly interests you. An amazing sight, a surprise in nature, anything that you notice around you that's interesting or confusing, like something that you see happening that you thought never would happen. And it makes you wonder, like, how does that happen? How does that work? I've never seen that before. For example, now if you're thinking about an astronomy one, sometimes I see planets at night, like Jupiter or Venus. And sometimes I don't see any planets at all. Like, I know that you can see Jupiter and Venus just with your eyes, but I don't always see them. Sometimes I don't see any. When I do see the planets, sometimes they're in one part of the sky. The next time it might be in another part of the sky. So that kind of confuses me. Like, I might wonder, what's up with that? Like, how do I figure this out? That's a STEM Expo project. That's exactly how it starts. So what's the next step then? And you think, okay, well, could I do this as a project? This is your time to wonder, come up with questions, maybe gather some information. I think for this one, an observational investigation would be great. An investigation of what is going on. How can you figure out what's going on with these planets? Think about what you know is true, like what you know you know. Let's say you're good in science and you're smart, so you know certain things are true. But how does that fit into the phenomenon that you just watched? Because sometimes we find out what we thought was true isn't actually true when we look at evidence. And you might be able to come up with a whole list of questions about your thing. And then you try to narrow it to just one good open-ended question. And that can be the basis of your entire project. For example, this planet thing is kind of interesting. I took some screenshots of the program I'm going to use in just a minute. And I just picked a date from a couple months apart. So in January, like tonight at sunset, in the southwest, Jupiter is visible. And this is correct to scale. Like, Jupiter is that bright compared to the rest of the stars tonight. I mean, you can't miss it. If you go out right now and look in the southwest, you will see a very bright dot. At least it was clear at sunset. As long as it's still clear, you will see it. You can't miss it. But then if we fast forward 3 months or 2 months, I think I went to March. Let's go to March at sunset. This is a little bit after sunset. I can barely see the sunset. It's a little after sunset, but I waited until it was fully dark because look. In the south, southwest, there's nothing. There's no planets at all in the evening sky in March. Fast forward to June. Again, none. There's no planets right at sunset. And if I keep going to September, Saturn shows up. In September, Saturn is in the evening sky right at sunset. By December, we've got Venus right next to Mercury, and then Saturn, and then Jupiter. 4 visible planets all in a line next December at sunset. But if I go backwards in time here, each one of these, they're all kind of in different spots. Whoops, I think I went the wrong way. I did. September and then December. Saturn is all we had in September. And then we got nothing in June. In March, there's none in the evening sky. In January, right now, we only have one. So we go from one planet to zero to one, and then we have four. And if I look in the morning sky, this is not my favorite time, but right before the sun rises in January, the moon is up. If we go to January 26th, early in the morning, Mars and Venus are both visible. Yep, Venus and Mars are visible before the sun comes up tomorrow morning. Let's fast forward to March. In March, not only are Venus and Mars there, but look, so is Saturn. How does that happen? And then if we go to June, this is why I did this. If we go to June, we've got Saturn, Jupiter, Mars, and then Venus and Mercury. All of these are in a line. These are all visible naked eye planets. And that just means you don't need telescopes or binoculars. You can just go outside this June, 5 planets in a row. Oh, it'll be in the news. All sorts of people are going to make up hocus pocus and tell you all these things that's going to happen because of it. And I can tell you nothing's going to happen because they line up. It's not going to make earthquakes. It's not going to change your energy. You're not going to have extra luck and win the lottery, although you might win the lottery. But it's just a really neat event to watch. And it's got a really cool word. When planets line up like this, 3 or more objects, it's called syzygy. It's a really funny word, syzygy. So this June, we've got a great syzygy. The bad news is it's before the sun rises, unless you're an early bird. If you really like to wake up early, a few minutes before sunrise in June, that's like 4 o'clock in the morning. What do we got here? Yep, this is 4:30 in the morning. You'll be able to see all 5 of these planets. Hey, that means June at sunset, there's probably no planets. How did I just get to that? If the sun is right below the horizon here, and all 5 of the visible planets are on the right side of the sun, are there any on the left side of the sun under the horizon? There must not be any there. And I can go to that here. I have them right here, I think. Oh, I do. Hold on. There it is. So here is June at sunset. There's the sun. No planets at all to the left of it. That's because they're all to the right of the sun at sunrise. So what else could we do to figure this out? What are some other kind of questions you would have about these planets as they move around in the sky? The best questions, address the phenomenon that makes you say, what's up with that? They're not statements. It's not telling facts. Questions are just questions, things that you truly are wondering. You can group your questions. You can classify them. Did you notice something? What happens if? What is the problem? Can I predict? And my question, I think, that I could narrow down to for this one would be, how can planets move all over the place in the sky? So that would be like my big question. How can planets move all over the place in the sky? Does anybody have any ideas? I don't even think I should show that one. What can explain why these planets are in all these different spots? Does anybody have an idea? Go ahead and put it in the chat or the Q&A. How could that be? Why are they always changing? Sometimes I go out and I see Venus and it's like so bright. And then the next time I look, it's not there.
Excuse me, sorry. One of the possible reasons, or somebody's wondering one of the possible reasons, is it because they form a line? The question is like, is it possible that they're in a line?
Interesting. Like, are they lined up? Ooh, that's a good question. I like that. Can the planets line up?
Well, and this this person is saying planets move, and maybe they all have different orbits, routes, or speeds.
Okay. And I think I like both of those questions a lot. I think that if you can find a way to explain why you're even getting to that question, you're on your way to understanding the concept. So what I can do next is, it's been a while since I've done a slide deck. I actually want to switch to this different screen. And I looked at this and I'm thinking, wait, hold on. This is what somebody said. Maybe this happens. Maybe they get in a line like this. I mean, is it possible for the planets to line up like this?
There's
What would it look like? If I was on the Earth, which is this third one right here, if I'm on the nighttime side, would all these look like they're in a line? And what if I looked on the daytime side towards the sun? There's two of them on that other side. I found this on the internet, and it's okay to do research on the internet. That's part of your project. I found a whole bunch of images, and this one intrigued me because it said on June 24th, all these planets are going to be in a line. And I wonder if there's a way we could check that. It says that it'll be Saturn and then Jupiter and then Mars and then Venus and Mercury. And the moon happens to be up on that same day on June 24th. I think this matches that other program that I lined up in June of 2022, and they're in the same order. So they both said the same thing. What about this picture? This looks like my textbook from when I was in 6th grade. Hey, and I look at that and I think, yeah, you know, when all the planets line up, they're all in a line in the sky, right? I mean, right? Aren't they? Or are they?
Well, I have there's one more question that might help with, I think, where you're headed. Since the Earth rotates on its axis all the time and all of the planets revolve around the sun, planets can appear at different places in the sky.
That sounds like a good answer to the question asked. Like maybe it's something about the Earth rotating and the planets revolving around the sun, and add in the Earth revolving at the same time. And those movements could seem very random. Ooh, this is a good one too. I found this on the internet, and I'm going to go back to that question too, because I'm going to go to a different screen. It says all 8 planets of our solar system will next come closest to being aligned on May 6th, 2492. That's like 400 years from now. And it says all of them are going to be in a line on May 6th, 2492. I don't really know what that means, being aligned, because I look at this picture and these don't look aligned to me. I would say that previous one, that looks like aligned. But is that the same as this? And is that what that statement means? Sometimes the things I find on the internet are more confusing than helpful. So I think I'm going to switch to this screen. I have this set up for tomorrow at noon. Tomorrow at noon, 12:42 in the afternoon. This is our entire solar system. That's the sun way in the center. And I'm going to scooch us in. I'm going to zoom in. This is the lineup that we're going to have tomorrow at 12:42 in the afternoon. Here's the Earth. Now, if you're on the daytime side, you'll be looking right at the sun. For us at 12:42, we'll be on the side of the Earth here that we can't see. And as the Earth rotates around, as we head into evening time, that means we'll be heading to the right side. We'll be spinning around this way. If you follow my cursor, this is the direction that the Earth spins. So evening, like right at sunset, is right along here. And if you imagine yourself being a human at this angle, heading into nighttime, you can see right there, that's the edge of nighttime. So you're on this side of the earth over here. If you look up in the sky to the left of the sun, the only thing you're going to see is Jupiter. We were seeing Saturn about a month ago, but now that the Earth and Saturn have moved in their orbits to the point where Saturn is behind the sun, we aren't seeing it in the sky anymore. And if I think about the other side, if I think about early morning, when you're on the edge of nighttime and it's just about, you're on this edge where you're just about to get on the bright side of the earth, you might be able to look up in the sky and see Mars and Venus. And I don't know if you remember, but that's exactly what my screenshots showed me a moment ago when I looked it up in that different program, The View from Earth, that Mars and Venus are the ones that we'll see in the morning. And right now, Jupiter's the only one we're going to see at night. But like someone said in the chat, life goes on. We're going to let it go. So if we're able to see Jupiter right in the evening time, watch what happens as we move forward in time. And I'm going to actually go a little bit faster. I'm going to fast forward us maybe a couple of months. Here we are in March. So now here it's March. And if you look, Jupiter is pretty much behind the sun. So at sunset tonight, if you're a human and you're right here on Earth, would you be able to look up in the sky and see Jupiter anymore? Is Jupiter in our view over here? It's not. By March, we won't be able to see any in the evening sky. But if you move to the morning time side of Earth in March, it looks to me like we could see Mars and Saturn and Venus. Let's keep going. April. Here we are in May. I'm going to go all the way to June. Oh, late June. So here I am on planet Earth. Now, I'm not talking about sunset. I'm not talking about when you're over here and it's starting to get dark out. Because if you do that, zoom out, and if you train your eyes out in this direction, there are no stars at all, or no planets at all. You won't see any planets in the evening. But if we think about going from nighttime as the Earth spins this way and you start heading into early morning, like right before the sun comes up, I'm going to zoom out so we can see everything. Look at that. It's hard to see them all, so I'm trying to zoom it so it's just right. And I think June 30th is too late. Venus actually has snuck over to that other side of the sun. But I think that we would be able to see Venus and Mercury over here, along with Mars and Jupiter and Saturn. Neptune, you can't see naked eye. Even though it's on this program, you can't see it without a telescope or binoculars. So all of those would be. So if I continue to watch all the planets as they spin and revolve around the sun, I speed it up a little bit. I wonder if there's any patterns that happen because of this movement. Are they yearly patterns? Are they monthly patterns? Are there patterns that take more than a year? I mean, I'm noticing that every once in a while, the Earth is passed by Venus. And I wonder if we're going to catch up with Mars. It looks like we're going faster in our orbit. So when is the Earth going to be lined up with Mars? Oh, it's getting closer. It's getting closer. It's getting closer. It's getting closer. Oh, look at that. 3 of them, a syzygy on February 22nd, 2027. Does this mean I'll be able to look up in the sky and see Mars and Mercury in a line? Nope, we live on planet Earth. So if you try to look at Mercury on this day, you'll burn your eyes because you'll have to look right at the sun and Mercury will be blotted out. The sun will be too bright. But if you wanted to look at Mars, you'd have to be on the nighttime side of the Earth. I didn't even notice. We're very close to having Jupiter lined up too. On February 22nd, 2027, you'll be able to look up in the evening sky and easily see Mars and Jupiter. Boy, they are both going to be bright. and they're going to look like they're really close to each other in the sky. Could I keep watching this and look for other patterns? If I waited long enough, do you think there's a time when they ever line up? Like that question asked? Maybe it happens where they ever line up. Do they ever line up all on the same side of the sun? That's actually a completely different question. So if I go back to our question, which was, how can the planets move all over the place in the sky? It's because the planets are in motion around the sun, so they move in their place in the sky. And my question would go even further. I wonder if I could predict it. Could I make a prediction of when I would see certain planets in the sky? If I just studied Venus, just Venus, when Venus is getting closer and closer to Earth like that, would I be able to see Venus when it's in front of the sun? How long do I have to wait for it not to be in front of the sun? Would I be able to see it when it's like this? If I was on Earth and it was nighttime, could I look and see Venus in this position? Would it be bright? What about when it's here? Bring the Earth back to be in front of us. If I stayed in one spot here and I just watched Venus go around the sun, wouldn't it be on the right side and then the left side and then the right side and then the left side and then the right side and then the left side repeatedly, time and time and time again? Could I use that pattern to predict when I'm going to see Venus in the evening sky? Do you think ancient people figured that out? I think of the Aztecs, and they revered the sun. Do you think they watched enough and paid attention to know when the sun would be on the right side of the sun versus the left side of the sun, which means seeing it in the evening versus seeing it in the morning? Those are all interesting patterns that you could look up. And the one last thing I do want to look up, all 8 planets of the solar system will next come closest to being aligned on May 6th, 2492. I want to go there. I don't know if I can go. I don't know if I can go very easily to that date. $24.92. I can't go monthly. Oh boy. And that doesn't let me scroll. If I could, I would go to $24.92. I'd be very curious to see if that internet post was correct, that all of the planets were going to align on May 6th, 2492, because I think there's other months where they're going to also be aligned well before 2492. But I would have to enter all that in. I could probably enter it in on the next program that we use. Maybe I'll give that a try. So a couple slides here, and then I want to go through what's in the sky tonight, which you'll be able to see in the sky if you brave the cold weather tonight and you want to go outside and look for Jupiter. And to help you get thinking about a STEM Expo project as you figure out your phenomenon or your problem. I really like phenomenon, but you can also come up with a problem that needs a solution. And you make a list of questions about your problem, about your phenomenon. And then Ms. McMullen was good to pointing out, always bring it back to, is there something that's testable? So for my planet thing, could I make a prediction and then test it? It might take me a couple months to do an observational test of when I see Venus. Right now, I know that Venus is up. It's actually behind the sun, kind of, but it will be coming up in the morning soon because of how it's moving around the sun. Could I draw pictures of the sun and how Venus moves around the sun and then make a prediction that in June, I'll be able to see it in the morning? And then I could test it. I can make a checklist and see if what I thought would happen happened. That's a STEM Expo project. It doesn't have to be an experiment with test tubes and chemicals or a volcano. It can be a project where you just have an inquiry that you want to figure out an answer to. Can you make a model or a model of the answer or a solution to your problem? How does distance in the solar system relate to the universe as a whole? These are ideas for astronomy related projects. Whenever you have a possible explanation or a pattern that you can predict, That gives you enough to have an entire Science Expo project. What kind of data will I need to figure out? How can I measure? Are there numbers in there that I'll be able to measure? How can I prove it with evidence? And often that means numbers, some kind of a data table. And I just thinking about astronomy subjects, the moon, the stars, the planets, Earth and sun. And I was wondering, what kind of projects could I do if I were a student and I wanted to learn more about astronomy? Every single one of these sentences, these little phrases, are entire projects that you could do if you wanted to do them. And we shared this slide deck in the chat, and we'll probably share it again for anybody that just came in. So you can totally access this slide deck, and you're welcome to take this and think about them and maybe use it for ideas for your project. And now I want to go do a little bit observing with the program that's called Stellarium. And I have this set up for about 1 o'clock in the afternoon. There's the sun. This is tomorrow, no, Wednesday. This is now Friday. I could go to, here we are. So here we are tomorrow, the 27th. It's the middle of the day. The sun is out, and I'm going to fast forward to sunset. And I noticed the other day it was not dark at 5:45. So it's not even quite, the days are definitely getting longer, but the sun starts to set in the 5 o'clock hour. It starts to get dark out. Once the sun goes down, there's still light in the sky for about an hour. And if we just let the sun set, you're going to start noticing stars in the southwestern sky. Zoom a little bit more, there we go. If you look down here, you can see the time going. We're at 10 after 6. The brightest thing in the south sky is Jupiter. After this program, if you go out, you will be able to see Jupiter in the evening sky. Oh, I see a great constellation showing up. If you've been to the planetarium, hopefully you can see Orion right now. There's some satellites going by. That is perfectly normal. And since it's about 6:40 right now, 6:45, I'm going to go to 6:45. All those things moving past, those are satellites. There are hundreds, thousands of satellites going around the Earth right now. And early in the evening, the sun hits them because they're up above the shadow of the Earth, and we can easily see them in the evening sky. And if I stop here at 6:40, there's our sky. Jupiter's pretty low. Jupiter's going to set soon. But I see Orion the Hunter, the 3 in a row. The belt is the giveaway. If I back up a little bit more, I can see a little bit more of the night sky. I could add in the lines. That's definitely Orion the Hunter. There's his shield. That little letter V, that's Taurus the Bull. The Great Square of Pegasus is up high in the southwest. Gemini the twins are on their side. They're kind of laying on their side. The two brothers are holding hands. I'm drawing the pictures there for you. Cancer the crab is right next to Gemini. Pisces the fish are right here. And that little thingy right there is Aries. I can't even remember what exactly Aries is. This is tonight at 6:45. Now, if you spin your body to the left, you'll be looking more towards the east, east-northeast. Orion the Hunter is still visible. Now it's off to the right, though. By drawing the lines, there we've got Orion's belt right there. In the east, Gemini the twins. And zoom in and look east, northeast, because right here, with its tail sticking kind of into the horizon, we have the Big Dipper. It's actually part of the Big Bear. So there's the rest of the bear. Her head is right there. And those are her front paws. The last 2 stars in the saucepan lead you to the North Star, and there's Little Dipper. That North Star that's not very bright. It's the 49th brightest star in the sky. This is Draco the dragon. It kind of snakes between the Big and Little Dipper. It's just a couple dim stars here. And then his head is down at this end. That's Cephas right now, right there. And then if we keep turning to the left, now we're kind of facing west, southwest, and we're back at where Jupiter is. Jupiter looks like it's in Aquarius, the water bearer. Yeah, because then there's Pisces, the fish. Looking straight up in the sky, up high in the sky tonight, you get a W, Cassiopeia the Queen, and Perseus, the superhero Perseus. He saved Andromeda's life from the sea monster. All the constellations in the sky have a story going with them. And then if we just let the night go on, stars rise in the east, they set in the west all night long. We'll face south to watch that. I'm going to fast forward a little bit. Here it is 7 p.m., 8 p.m., 9 o'clock. 9 o'clock, Orion is just right overhead there. Now after 9, Orion is starting on its way down along with Taurus the bull. The twins are kind of standing up now. They were on their side and then they went up and now they're standing right side up. There's Leo the lion. It's about 4 o'clock in the morning now. 5 o'clock in the morning. We've got the moon up. And at 7 o'clock in the morning, the sun comes up. We just can't see the stars anymore. If we go back a little bit so we can see the early morning. Venus and Mars. Those 2 planets come up at about 6:30 in the morning, which I'm always up by then, but I'm not always looking out the window. But we've got Mars and then Venus, and then the moon is off to the right from them. And this looks like Scorpius. So that star is probably the heart of the scorpion, Antares. And then once that sun comes all the way up, the stars are still there. We just can't see them because the sun is so bright. Ooh, and I saw Mercury for just a second. Venus, Mercury, and Mars all visible early morning. Cool thing about stellarium is I can turn off the light in the atmosphere. And even though this is the sun in its daytime, these are actually the stars and planets that are up during the day. Saturn's just on the other side of the sun. Mercury, Venus, and Mars are up tonight. So I know we're running on our time. I see there's a question about the template, and Ms. McMullen can probably answer that better. When and where will the template?
Sure, yeah. So
that's a great question.
It is a great question. We can, so Amber, we could put it in our chat again. So you can click, Mrs. Valencia will put that in the chat again. So you can click that. And what you're going to get is the slide deck that has the templates. And then the other thing, when you register, we will, for whatever you register for, Ms. Rodriguez Horn will send you guys an email, and then that email, it will have the different template options in it. What else is in that little registration packet? You always do.
Oh, mute. Yeah.
Is your audio being weird?
No, connecting, but
sorry, it's because I took my headphones out and for some reason it doesn't like to connect after I do that. So in the registration packet, there will be, I think you said it, I'm sorry. I was trying to reconnect. First name, last name, or maybe, yeah, first name, last name, grade, teacher's name, because if you want a trifold board, if you're choosing to do it in person, we'll send you one of those and I'll need that information. I think we're bringing back t-shirts this year, so I may ask you for your t-shirt size. And then we're still working out how we're going to stagger the times. So I may ask you if you like to be first thing in the morning, or if you would like to be later on in the afternoon. I think that's pretty much, I try to keep it quick so that you don't get overwhelmed, but I think that's pretty much it.
Yeah, and then we'll send you a link to the templates. So if you're going to be in person, then we'll send you the updated link for the in-person. And if you are doing the virtual, then we'll send you the updated link for information for that. But right now, Amber, in that slide deck that we just put in there, that link will take you to the slide deck. And in the slide deck, you can see that we have them all there, with the exception of the virtual one we have to update. The virtual one is actually pretty tricky. So that one takes a little bit more to update.
We're cleaning it up and making it a little bit easier to use so that any project could just fill out the answers in it. So there's a couple little glitches on some of the pages that we want to fix. But otherwise, once you register, you'll get all the templates, you'll get all the information, and can look it over and figure out what you're going to do.
And you get all the people. You get all of us. So if you need help with it, or I don't know if people have ideas now that they want to, put in the chat or run by us. Are there any other questions you guys have for us? And so you guys know next week we'll do, it'll be a different sky show. You'll always have what's in the sky tonight. Our department's theme question is what's up with that. And so we're going to be talking what's up with that all the time. That's our goal, is to get you guys, you see something interesting, what's up with that, and you want to figure out what's going on. Any of those kinds of things are what we want you to be looking for between now and next week. We'll do another sky show for you, and then we'll have a different example. So each week we're also going to have another kind of observational thing that we'll present to you guys, get you thinking about how you could turn that into a project. And then also we always have time to answer your questions. So if you guys have more questions for us, or
anything. The presentation that I did with the planets moving around the sun is an excellent example of an observational pattern project you could do. And part of it would be making those observations, but there's plenty of open software like Stellarium that's free and online, where you can enter dates and you can go one day at a time. And it's kind of interesting to watch, going one day at a time, how the planets go at different speeds. I think Ali had said that. And if you watch that pattern, it becomes predictable, but you have to watch the pattern. And how could you show a judge, and I'm calling it a judge, but we're not really judging, your feedback person, how could you show your feedback person that you really did the observing? And you could make sketches, you could do screenshots and put them across your board. And then you could write a sentence about what connections you made when you realized you saw that Venus goes around the sun in a pretty tight circle. So you get about 1 month when it's in the morning, 1 month when it's behind the sun, 1 month when it's in the evening, 1 month in front of the sun, 1 month, and it just repeats and repeats and repeats.
I'm going to put Stellarium in there. I don't know if I'm spelling it right, though.
Yes, it's Stellarium I think it's a .org. It's free open source software. Anybody can use it. You can download it on your own computer if you want, or you can just click where it says use web version, and you don't even have to have it downloaded. You can use it right on their website. It's a little watered down, but it still totally works, and you can enter the dates.
They haven't tried it on a Chromebook, but I wouldn't imagine that it wouldn't work on a Chromebook either.
No, I think it does.
Yeah. Anybody, I see somebody raising their hand, but I don't know. Okay, it went down. It was an accident. I know, it's right there. It's hard to. What other questions do you have for us? Anything else? Well, I hope you come back next week. It's going to be a different show. There'll be a different example. You can come with us. Maybe everyone here can come back with an idea of a project, and we will, we'll ask you what your project idea is, and we can kind of help you through it. We can talk through it. We can make that on our agenda, and then tell everyone. we have 1,000 links to give out. We want to give out all 1,000 links for the 9th. Well, for next week too, but for the 9th, we want to have as many people as possible. Oh, can anyone join? Anyone can join. So this is open K through 12. Sorry.
Yes.
12th grade. And also they don't have to be U46 students. They just need to live within our boundaries. So if you have friends that go to a different school and you want them to be your partner, and maybe they go to the STEM school, maybe they go to St. Joe's, maybe they go, wherever they go, you can work together, or they can also enter and get our feedback as well. Yeah. That's a great question. Any others? Okay. Oh, wait, we got a Q&A.
Oh, I'm answering it right now. It's
Okay.
Stellarium. Google the word Stellarium. And mine is downloaded. I'm not on the website. So by the time I look it up on the website and make the link in the chat, you will be able to Google it yourself and go to Stellarium. It was made by planetarium operators, and it's been around for many, many years now, and they've perfected so much of it. There's so much in it. So the watered down version on the website is actually perfect to start with, because otherwise there was just so much stuff.
All right, it's an org, a .org. Okay, I think I was able to find it for you.
Okay, that sounds right. Stellarium.org.
Yeah, it's a pretty cool program.
Yeah, great way
That's another thing,
started.
yeah, and that's another thing our team is really good at is resources. And so if you came to one of these or even sent us an email and said, I want to do this kind of project, we're going to ask you and make sure that you have an idea of what you're going to do and you've got a question. But if you need a resource, we'll help you find that. We can help you refine a question so that it's more testable.
I saw that somebody asked, is it for high school? Absolutely. And of course, they would get more sophisticated for high school. And Stellarium is a great opportunity. And just off the top of my head, I think about the angle that the sun rises, because we're spinning on an axis at a 23.5-degree tilt and going around the sun at the same time. Does the sun rise at the same angle that it does in the winter versus the summer? Does it rise in exactly the same spot? Normally, that would be an observation over a year. You have to get up every morning and either take a picture or make a drawing of exactly where you're seeing the sun come up. But on Stellarium, you can plug in the date and you can take a screenshot of where the sun is and not have to worry about it being clear or not. And you can start to draw some conclusions based on your data. And that's a STEM Expo project.
Yeah.
That right there is a project.
Yeah, it's our favorite part to see you guys come up with your own, you can tell when you're talking to somebody about the level of passion for their project. And we get so excited when we meet young people who you can tell that they're talking about something they were super interested in learning about and doing research on. And that's what we want to create in U46. We want a whole culture of science. We're all scientists. And we want to promote that. All right. Well,
Thanks for coming, everyone.
thank you for your show, Mrs. Hernandez. It was really good, as always. I'm going to be going right outside to see what I can see.
It's 7 o'clock, so it's getting pretty low on the southwest horizon, but you should be able to see it.
Okay. I'm going to go out and do it. I hope everybody else does too.
Put a hat and a coat on.
Very cold today. Yes. All right. Well, thanks everybody. And we hope to see you next week and the week after that.